Hi, welcome to video 9.4 on two-way frequency tables. So on this, we're going to do number 1 and 3 together, and then you are going to try number 2. So we've got some information here, and we are going to put these in two-way tables, which means that our data is talking about a person's being a member of more than one category. So, for example, here we have 195 males, so we would put that 195 in the total category. Same thing with the females, 126 females total, and then a survey showed that 110 males and 84 females ride the bus. So that means that we have, a total of 110 males ride the bus. So that's got 110 males ride the bus, and if there's 195 total, then we figure out that there are 85 males that do not ride the bus. Same thing with females. We have 84 females that do ride the bus, and so if we take 126 minus 84, we get 42, meaning that there are 42 students or females who do not ride the bus. And so then we just add down here. This will give us the total students that ride the bus, which is going to be 194. We add these, and that'll give us the total students that do not ride the bus. And then here, we should be able to add our males and females and our students that ride the bus and don't ride the bus and get our total here, which is 321 no matter which way we add it. Okay, let's take a look at the bottom one here. So we've got Ricardo. He surveyed 110 8th grade students. So that means that's the total right here, 110. There are 60 students who have a part-time job. So total with the job is 60 students, and 48 of those are on the honor roll, leaving 12 students who are not on the honor roll. Half of the students who do not have a job are on the honor roll. So that means right here we've got 60 is a job, total of 110. That means 50 of them total have no job, and half of them are on the honor roll. That means we split this in half, and we've got 25 and 25. So that gives us 37 and 73. And then we're going to look at some percentages here. So we want to know the percentage of students who are on the honor roll and have a job. So on the honor roll and have a job is 48. So we've got 48, and we want to know the percentage, and in this particular case we want the percentage out of the total. So we're going to divide that by 110. We want to compare that to percentage of students who are not on the honor roll and have a job. So that's these guys. So that's going to be 12 divided by 110. And then, of course, it's a percent. So you multiply it by 100, or you move the decimal 2 spaces. So 48 out of 110, that gives us approximately 44%, and 12 divided by 110 gives us approximately 11%. Okay, so use the information to fill out the table and then find the percent of students who studied Spanish out of the total students who studied Chinese. So pause it and give that a try. All right, come on back, and there are your answers right here. Okay, so looking at some of the information here, so far we've worked with quantitative data, meaning that it's got numbers, and single variable at a time most of the time. Sometimes we've done dual variables when we've been talking about scatter plots. We're also working now with categorical data, so how many students fit into a particular category, for example, brown eyes, blue eyes, whatever. We're not going to do this where we survey our class. We can look at this information right here. So we want to know how many students had blonde hair and blue eyes. So we go to eyes, blue, hair, blonde. There are 4 total. How many students had red hair total? That's going to be 4 right there. Okay, we are not doing that because that's asking us to use class data. Flip over to the back page. Okay, we've got the same two-way table that we looked at there. And we're going to be looking for some information that we can get from that table. So looking a little deeper than just finding a category and putting the numbers in there. What is the conditional relative frequency of having green eyes if you have red hair? So that's the equivalent of asking what percent of people with red hair have green eyes. So we have 4 people with red hair, and 3 of those people have green eyes. So 3/4, 3 out of 4 is 75%. So 75% of our redheads have green eyes. Conditional relative frequency of having green eyes if you have black hair. So there are 9 people who have black hair, and 1 person has green eyes out of that. So that's going to be, let's see, out of the black hair, we have 1 person that has green eyes, so that's going to be 11% on that. Okay. Does it appear that having green eyes has a dependency or at least an association with having red hair? Yes, because we have, it's very rare to have green eyes, and it's rare to have red hair. Out of our 20, we only have 5 people who have green eyes, and we have 4 people who have red hair, and 3 of those people are the same in both categories. 3 of the people are counted in both categories. So I'm going to say yes, because even though it is rare to have green eyes, there's only 5 people, and red hair, there's only 4 people. They coincide frequently, meaning they're on the same person often. However, something is kind of wrong with this data, and that is that we only have 20 people that we're looking. However, I'm going to put this is a small sample, so I don't think we can make any big overarching conclusions out of this based on only 20 people that we're looking at. Okay, this one, is it more likely that a person with black hair has blue eyes, or that a person with blonde hair has brown eyes? Okay, so our people with black hair and blue eyes, that's 3 out of 9. So that's going to be 3 out of 9, 33%. And a person with blonde hair has brown eyes. So that's going to be 2 out of 7. And that's going to be about 29% there. So more likely to have blue eyes if you have black hair. Blue eyes for black hair than it is to have brown eyes if you have blonde hair. Or at least in this very small sample that we're looking at. Okay, so this one, we've got a survey of 52 graduating seniors that was conducted to determine if there was a connection between the gender of a student and whether they were going on to college. Based on this data, what is more likely? That someone going to college is female, or that someone who is female is going to college? So these may seem like the same thing, but they're different. So let's look at the going to college. How many of those are female? So our students who are going to college, there are 29 of them. So that's going to be 29 total. And the students that are female that are going to college are 13. So we're going to do 13 divided by 29, and we get about 45%. So 45% of our students that are going to college are female. However, if we look at our females, we want to know what percent of them are going to college. So we have 22 total females, and 13 of them are going to college. So if we do 13 divided by 22 times 100, we got about 59%. So that means it's more likely if you're a female to go to college than if you were randomly at a college and picked up someone, would they be female? That would only be about 45%. And if you randomly picked a female, it would be about almost a 60% chance that they were going to college. So once again, relatively small sample. We're only looking at 52 people. But for this particular sample, that's the data. Okay, make sure you write down any questions that you have, and we'll talk about it in class.